Hello, my name is Robert Winterbottom. I'm a software engineer at Asymmetric and the technical lead of the Phoenix team, which is our FHIR development team. And today I want to talk to you guys about code generation and what we're kind of doing with that at Asymmetric. So at a high level, code generation is, or metaprogramming, is a process of writing programs that create other programs. This is really interesting because it gives engineers the ability to solve really complex problems very efficiently without, you really couldn't do problems this way without code generation. So when we first got into FHIR, we started writing just a couple resources at a time. So we did a patient resource and an observation resource. As time went on, we started doing more resources, and we really went after US core first. This took a significant amount of effort. After we did US core, we started looking at what was next. So when we started looking through the FHIR spec, we realized how big it really was, and that was just for one version. So if you wanted to support DSTU2, STU3, R4, various profiles, and you want to do like GraphQL and REST, it was a lot of effort. It was hundreds, if not thousands of hours. And manually writing all this code would probably introduce a lot of errors. So it's very easy to make mistakes when you're doing that much physical writing. One thing we realized when we did this was that logic is very repetitive. So we started thinking there's got to be a better solution than this. So initially we came up with this idea of generating code, and this was kind of our first blueprint for our plan. So we wanted to start with structure definitions because this is kind of the source of truth for a resource. It defines what it is and what it can do. We wanted to ingest all those and create a data structure. And then from that data structure, we wanted to pass it into a renderer and have it spit out server code. Server code could be JavaScript, it could be .NET, it could be pretty much anything. So we started to think about this, and we made a couple passes at it. And with our first implementation, we came out with essentially just resources. But currently, we're parsing all structure definitions, all search parameters. Once it goes into our data structure, we're able to do pre-validation on it. So you can look for missing dependencies. You can try to automatically fix issues with structure definitions. So let's say, for example, you have a patient resource. And with the patient resource, you have a search parameter defined, and it's the type token. If you don't have that token definition in your structure definitions, you can't really generate code for that and guarantee it's going to work. So if we know that we're targeting a REST API, we know that REST is going to treat all the parameters as strings, we can just kind of ignore that error for now. It's not something that we need to worry about at this stage of our server, but maybe in a later layer, like when we're trying to generate queries, we can worry about it being a token versus a string. But this is one of those things that we can just kind of automatically fix, or we can do whatever we want with it. Another thing that we started doing was, as we were generating code, if we found a bug, we found that we'd have to regenerate code. Because the last thing you want to do is fix your generated code, and then a month later regenerate something, and then reintroduce all these old bugs that you fixed. So as we were doing this, we started taking all the logic from our generated code out and putting it into separate packages. This way we could test things individually, we could version them individually, and then not worry about having this problem with our generated code. So this worked really well for us. At this point, we started going past just resources. So like I said, initially we just did models for resources. Now we're doing the schemas and inputs for GraphQL. We're doing custom scalars, so things like positive int, we're not just remapping them to GraphQL primitives, we're actually generating custom scalars for that and writing the logic for that. We're also able to stub out resolvers. Query mutation declarations, so you can generate enough code that you can set up that base GraphQL schema. You can also set up the instance schemas for all the individual endpoints. Arguments as well, so we can look at the search parameter resources, and knowing what the search parameters are, you can start specifying what parameters GraphQL should accept on what endpoints. And then registration code, which I'll touch a little bit on the next slide. And then on the REST side, pretty much the same thing. So all the models, controllers, services, and even response and error handlers. So if the MIME types change across different FHIR versions, you can add that into your generated code and make sure that that's set appropriately, depending on which version you're supporting. So, excuse me. So when we did this, each set of generated code, we kind of treat this as a package. And luckily for us, our server is kind of written in a way where it discovers these packages and then just injects the router and any other server components into them. So when we did this, we initially tried it with DSTU2, STU3, and R4. And we were able to just generate a new package, dump it into this directory, and let our server figure it out and spin up that endpoint. And it actually worked really well. You can also do GraphQL and then do everything side by side. So the big advantage to this is that one package. So these metrics are from R4 with GraphQL, but it's over 2,000 files and 200,000 lines of code in that one package. And doing that manually would take forever, but using this code generation tool, it can actually take a couple of seconds. So we were pretty happy that when R4 was initially announced, we had GraphQL schemas for that within the first day or two. And then by the end of the week, we already had a PR up that we were able to do some testing on it and get it released. So doing code generation, you're able to move a lot faster than if you weren't doing code generation. But you can't stop there. So one of the tricky things with doing this is it's a lot of code. You need to make sure that it works correctly. So at a basic level, unit testing. Does it compile? Does any resource just happen to be the name of a reserved word in the programming language you're targeting? You have to make sure all this stuff kind of works. The second step is integration testing. And that's actually generating query, hitting an endpoint, validating you're getting the correct response codes and that kind of stuff. So at this point, sending a query through the whole system and making sure you get the expected response. These first two are actually automated, which is really cool. But then the last step is something that we kind of do manually, and this is kind of like the QC step. So once we've gone through all the automated testing, we deploy it to a staging server, and then you can use a tool like Aegis Touchstone or any of the other tools out there to do a conformance test on your server. And this will actually write resources in, read them, modify them, pull them out, and that kind of stuff. And that's really important to have as kind of your last point. So at this point, we were pretty happy with what we were doing. It was working really well. We were able to move really fast. So we started thinking about kind of the future steps. So currently, we're doing basic structural validation, but we do foresee it getting to the point where we can actually do full validation inside the generated code, so we don't have to have a separate validation server to send everything to. We can just kind of validate everything coming in. We also want to generate code for other services. So when we hit that renderer layer, we don't want to just render JavaScript and GraphQL code. We might want to do GraphQL schemas. We might want to do .NET, Java, other potential servers. So right now we're doing just our open source servers, but we're going to expand that to potentially other things in the future. And then for me personally, automation would be really cool. So I've been getting into DevOps a lot lately, and what I'd like this to be is that by the time R5 is announced, I don't really have to lift a finger. It'll just pull down the structure definitions, generate a package, deploy a server, test everything, pull in the latest R5 package, and then just send me an email to say, hey, R5's up, go test it. So that way I don't literally have to do anything. I just wait till the email comes in, and then I go to Aegis and do my conformance test. And then something that we actually just released recently, and you can find out more about this on the Asymmetric Healthcare website, is we have an early access program. So we're looking to work with other people and see if we can maybe apply this to your use cases. You can go to this bit.ly URL, like I said, go to Asymmetric Healthcare, you can read about it, and then we have some forms there if you want to contact us and find out more about this. All right, that's it. Thank you very much. If you have questions, feel free to ask anybody in this kind of teal colored t-shirt. We're all kind of walking around, so. All right, thanks.
Okay, good morning. My name is Hallel Gomez. I'm an integration technical specialist at IBM, but focus on in the healthcare space, and I'm going to present what we call the FHIR API Sandbox, which is basically an API management platform for FHIR. What is the challenge, what we are trying to address here? I mean, do you have enough challenges creating your FHIR server? I mean, creating the resources, you just had the session to how you can generate code. But now, if you want to expose that to external entities, which is at the end the final goal, now you need to worry about security, how to manage all the governance, how to do the application registration that wants to use that APIs or your FHIR server, and so on and so forth. So you can build that inside your FHIR server, or you can use something that is already out there. And that's kind of the value proposition of the sandbox we are proposing. So where you can have an API gateway as part of it, where you create a facade for all your FHIR APIs, so now you have all that benefits for that. And security is just the tip of the iceberg, because it is that you can do all the security aspect that is there, all the management of those APIs, socialize the APIs. I mean, part of the challenge as well is, I mean, do you cover or have the conformance for all the specification on FHIR, just a piece, or what areas? So I know we have the conformance area, but socialize what aspects are covered, that's important. I mean, and we heard yesterday about the monetization. I mean, how I'm going to charge. I mean, how do I track all that information? And also the analytics. I mean, if I'm getting errors or how many times a day an API has been called. So again, you can build all that into your FHIR server, but why to do that instead of using something that is already built for you. So that's kind of the idea here. And the challenge is that I have a few minutes, so I'm going to skip these charts. You will have them available as part of at the end of the session. And what I want to focus is more on an actual demo that shows basically what I'm talking about. So let's say you have built your FHIR server. I mean, you have access to it, and you know a patient ID, and you want to check kind of a prescription. And you can make a request, and you get a response, and that's fine. But now, at this point, I have no security whatsoever. Whoever knows my endpoint and has access or knows a patient ID is able to access that service. So if I add, as I mentioned before, an API gateway in front of it, and now I change my URL so I don't have access directly to my FHIR server, if I click send, then I get an unauthorized error. So as simple as that, putting an API gateway, I'm able to have restrictions on the FHIR server, on the resource that I'm exposing. But again, as I said, this is the tip of the iceberg. And okay, so here it says I'm unauthorized and my application is not registered. So how do I access, or how do I get an app or register my app that I can access the resource at the end? So as part of the solution, we provide what we call a developer portal, where you can deploy your APIs, all the FHIR APIs. And at this point, again, in the interest of time, I'm already registered into the portal, but this is self-service. So if you have your FHIR server, you can stand up the developer portal, and whoever wants to access your server will come here, create an account, and start from there. So in here is where you can say, I want to register an app. I already have some created, but because now I'm the consumer of your FHIR server or a FHIR server. So I can create an app here. Again, I could add more description, just for interest of time, is just giving a simple name, DevDays demo. And the important part is that I get a client ID and a client secret. Again, and this is not managed by my FHIR server. The platform, the API management platform, is doing that for you. So you get it there, and you get as well the client ID. And something that we have, for instance, is you need to make sure that you save this information. This is not accessible anymore after you create your app. So those are the kind of things that you have, again, and you focus on your FHIR server, and you let the API management platform to manage them for you. And once I have my app, the other aspect is, in that same developer portal, I can see the APIs that I have available. So in this case, I have many, but the one that we are interested is in my FHIR APIs. And in your case, you can only have the FHIR APIs. So here I can see the APIs that I have available. And you see here, it is where you can say subscribe. And that's going to trigger a flow that says, OK, I want to access that API, whatever FHIR API you have. You will get a notification, and you can approve or reject that request. So again, you are removing the burden of handling all that aspect on the FHIR APIs instead of doing that inside your FHIR server. So, and in this case, the other part that you have in the developer portal is that you can test some of the APIs. So again, if we go back to my patient ID, medication request, and I go back and I know that I have my sheet here. Just let me get my patient ID from here. And I call the operation, I get the unauthorized. But you see, I have many applications, and I already registered one, which is my FHIR app. And I can call the operation, and voila, I get a response back. Again, my FHIR server didn't care about this. All this was managed in the API management platform. And you can have many ways of do authentication. So this one was the simple case, just with the client ID. But you can have OAuth application, OAuth access code. So let's say we say OAuth application. In this case, now I'm acting as an application that is going to be consuming my, my API. So now I need not only the client ID, I need my client secret. So let me go back here. Grab my client secret. And since this is OAuth based, I need to request a token. Again, and all this is handled by the platform. I get the token, I call the operation, and I get my response back. So again, that is to simplify how you manage all this. And you can create this. The other aspect that is important, as you can see in the other area, is all the analytics part. So every time that I'm making a request, I'm generating a dashboard, because now that gateway is feeding an analytics area. So here I can see all the requests that I got. So I have the 401s that are the not authorized, kind of the average response time, and you can have many others. So let's say I have the 85 here. If I go back here and I call the operation again, I have a refresh of every 5 seconds, and in theory, now I have a couple of extra APIs here. So you can see all this information, and if needed, you can drill down and see each one of those API calls if you want or you need to. So again, you get that kind of aspect. Also, here you can see the community. So who is registered in my portal? What applications are there? And from here you can say, I mean, maybe somebody is doing some sort of fishy things. From here you can say, hey, I can stop, suspend this application. So all the governance aspect is focused in this area. So your FHIR server is secure, and you focus on all the business logic inside your FHIR server. And just the last piece here is in terms of how you create all this. So basically, well, the most important part is that this is based on the standards. So OpenAPI is a way that you expose things using the API Connect platform. So here I have my API, and so all the security aspect is managed here. So I have the OAuth application, OAuth for access code, and so on and so forth, and you can have all this information. So here is where I enforce all those elements. So I can, when I say I have the security, you say which one of those you want to use. Again, and that you don't need to worry from your FHIR server directly. You have it here. The other aspect is, again, you can group APIs in something that we call products, so that to bundle them together. Again, it's not a bundle in the sense of a FHIR resource. It's kind of you package the different APIs if you want. Again, I have many here. This is the one that I'm using. And something that you can have here, again, for interest of time, I didn't see, for instance, you can say visibility. You want to publish that, and only the people that is registered into your portal can see the APIs if you want to, or you can make it public, but you can only subscribe if you are registered. Again, all the governance aspect is managed by the platform. So you have the APIs, you have plans. Usually, I mean, you can say, I want to, for this particular app, I don't want to expose more than 10 APIs per second, per minute, or whatever, for any reason. So you can define those kind of plans here. And this is another key aspect of governance, request subscription approval. So at this point, by default, I have everybody that requests access will be granted, but you can limit that as part of the platform. So you can see the idea is that you focus on the FHIR server, and you have an API management platform that allows you to manage all those APIs, add security, add governance, all the socialization, and manage all those aspects for you. So to summarize, the idea is that you have a FHIR sandbox based on IBM API management solution called API Connect that you can use to expose and secure the FHIR resources or the FHIR APIs that you have available. And if you want to play with it, you can access the developer portal. That's a link. You can register. I mean, it's public. I will need to approve it, but I mean, most likely I will do. If you want to try the full experience, not only the developer portal, you can try for free, access that. We have available in IBM Cloud. And if you have any questions, that's my email address. Feel free to contact me. I will be around the rest of the day. So that's it from my side. Any question?
So if I understand this right, all patient data is going through IBM, right?
In this case, yes. This is using IBM Cloud. Yes, we don't store anything. If you want to, this can also run on-prem.
Oh, okay.
Yeah.
That's what I'm used to.
Yeah.
But the normal thing is that the hospital would do a business associates agreement with you guys?
That's one option, yes. And again, due to the time, that's all from my side. I added a couple of backup charts at the end that you want to review later on. I mean, to understand the flow and the different components is there. But you know, I mean, there's another presenter. So any other question? If not, again, you can talk to me afterwards. Thank you.